Now these kind of probabilities here like this are called conditional probabilities because there's a condition attached to them. Let's make up some silly ones and we can see what we mean by conditional probability. Conditional probabilities. I don't know if I don't know if you need to write these down or not. You can put them down at the bottom or something. Let's use these letters here. Let's use the letters. What? M is going to be. We're going to use M for. Now let's see. M is going to mean you bring your math stuff home. A randomly selected student brings their math stuff home. Randomly selected student brings their math stuff home. Okay, what's the probability on any given class that might occur? What do you think? What do you think on any given class? What percentage of people in this class bring their math stuff home?
1 out of 1,000.
1 out of 1,000. I think it's more than that.
This class is 30. 2 out of 30.
You think 2 out of 30 people on average bring their stuff home?
I think 1.
Let's give it as a percentage here. Can we bump that up to maybe 10%? Is that what you're saying? We're very. Don't forget that this is going on the internet. Do you want them to think you're all slackers or what? You really think it's 20%? I mean, okay. I mean, it probably is 20% because you're forgetting all. There's times when you might bring your math stuff home. Now, event T is going to be yes, bring your stuff home. I never said anything about actually using it. I just said bringing it home. T is the event big test next class. Okay? What's the probability of M given that event T has occurred or is occurring? You think so? You think we still have 20%? So if I say huge test worth 20% of your mark next class, you don't think that changes? You really don't.
Maybe up 1.
You might think they're going to bring it home and study, but they're just going to be like, no, I'm going to go home and study. Or they'll look up for like 5 minutes and get bored. No.
Well, they brought it home then, didn't they? You really think it's the same, eh? Okay, well. Okay. Well, let's ask this one then first, because I'm sure you're going to tell me something different here. What about chance of M given that T has not occurred? There is no big test next class. You think it's still 20%?
No. 10.
Now it's 10? And you really think this was...
No,
I really think you're... I understand you're trying to be, ooh, we don't study. Yeah, I get it. I get it, the joke. Like, I get the joke now. I mean, it's... that's no big surprise, okay? But let's pretend that it's 30. A few more people decide they better bring their stuff home. The numbers are not that important here, but the concept that if I ask you now, are these events dependent or not? Yes, they are. In everyday terms, you could say they're dependent because if we know this is happening, obviously this is going to change, right? It probably will. For some of you, maybe it won't, and you just either bring it home or you don't, regardless of whether there's a test. But if you think of the group as a whole, more people are going to bring their stuff home when there's a big test next time. Mathematically, if you want to show that they're dependent events, you need to look at these two things. The probability with knowing that's happened and the probability of knowing it's not happened. If those are the same, and they're the same as this for that matter, then, like if these were all 20%, then you could say these are independent events. I think some independent events would be if I put one here that said S is Mr. B saying something that starts like this. You really should study should study, blah, 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 right? Dot, dot, dot. I think if we look at probabilities of that, if we add that to these events here, if we say, what's a chance that you're going to bring your math stuff home? Given, you know what? Get math stuff home given that I said you should study, or bringing math stuff home given I didn't say you should study. Do you think that probability changes? I don't. You're grade 12. You're too old now. You're set in your ways. You're going to do what you're going to do. You are. If you tell little kids things, they listen and they say, "Oh, I better do that." You guys are established. You're set in your ways. I think you're either going to study or you're not going to study, regardless of what I say. Right? If I say big test next day, yeah, that'll do it. But if I just say, you know what, if you want to do well, you should study. Da 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 da. You in the back of your mind know you should study, but I don't think it matters what I say. I think you know you should, and so on. Anyways. That's just to get at the idea of conditional probability. That thing added on to the end here, this is a condition you can attach to this other probability. You can think of lots of things that you can think of that are dependent events. It's hard to tell for these kind of events, we don't know because we're making these numbers up. You couldn't do this as theoretical probability counting unless you did it. You could do it experimentally and do a survey or monitor it all year. How many times did you bring your math stuff home in the last week or the last couple of weeks? We're going to look at simpler things that are cards that we can actually count and figure out are these dependent or not. We're going to look at this one now where they are independent. Can you go through and fill that one out? Notice this one is, of course, with replacement. Can you first of all make a table the way we did? Can you then fill these things out and see what's happening and maybe answer this question for yourself? Why are they independent? I'll give you 5 minutes to do that because I don't think it'll take much more than that.